Hello everyone, my name is Rahul Baranwal and today we will discuss about the quality of service. So in that we will cover what is quality of service, why do we need this and classification and marking in layer 2 technologies. So let us imagine that internet is like a big highway where different types of vehicles are traveling to their destinations. So actually vehicles is our data packets and destination could be computers, devices or servers. So quality of service is like the traffic rules and signals that help and ensure that important vehicles get to their destinations quickly without any problems. So here important vehicles is our critical applications of organization, right? So I'm taking one scenario here. Let's suppose this is our organization and this is the big ISP. So it could be AT&T, Verizon, Orange or BT, right? So we have asked ISP that we need 10 Mbps link, right? And in our network, we have used 1 Gbps link, right? Actually, we are using the multiple applications in our organization such as Gmail, Facebook, YouTube, MS Teams, Skype, right? So that generates HTTP traffic, voice traffic, video, FTP, TFTP, and many more. But voice is a very critical applications that should not be, and we think that should not be dropped, right? And there should not be any delay in that. So how can we ensure that this traffic should not be dropped? And we also know that the default mechanism of the queuing is first in, first out. That means suppose any traffic comes here first. I'm just assuming that this is HTTP traffic. Okay, this is HTTP traffic. And the size of HTTP traffic is around 1500 bytes. Okay, so definitely it will go out first as per the default mechanism. But after that, if our voice traffic will reach here and the size of voice packets is around 250 bytes. Okay, so there is a big difference, right? So we have to wait until our HTTP traffic goes through. So what we actually need to do, or we need to make sure that our voice traffic should go out first. So for that, we need to use actually classification and marking, and we need to give the priority to our voice traffic so that it reaches to the destination first. After that, our HTTP traffic or other traffic can reach. So this is the main significance of the quality of service. And in another words, actually we can understand. Suppose this is a big ISP, right? So it might be had multiple customers, thousands of customers. Like you have taken the 10 Mbps link, might be different customer has taken 500 Mbps or 20 Mbps or 50 Mbps link. So how ISP will ensure that this customer can take only 10 Mbps link, not more than that? Or any other customer, how this ISP will ensure that that customer can send their traffic only 10 Mbps or 50 Mbps, not more than that? So this can be performed via using classification and marking. Actually, ISP will use classification marking on this interface so that this customer can send traffic maximum 10 Mbps in one go, right? So let's move on the classification and marking topic. Actually, classification and marking we can apply on layer 2, layer 3, and layer 2.5 as well if you are running the MPLS in our network. So as we know that there are multiple technologies in layer 2 technologies such as Ethernet, frame relay, SDLC, PPP, ATM, right? But we can perform classification and marking only on Ethernet, frame relay, and ATM. Actually, there is a reason behind this here, we will learn later. So actually in Ethernet switch, we apply quality of service only on the trunk port, not on access port. Why? Actually, we know that trunk uses two encapsulation protocols, right? .1q and ISL, and .1q has 4 bytes of header. In that, 3 bit is reserved for quality of service, and that bit is known as class of service. But in access port, there is nothing like this. Means nothing is reserved for quality of service. That's why we don't apply quality of service on the access port. Similarly, in frame delay, 1 bit is reserved for quality of service, and that bit is known as discard eligibility. And in ATM, 1 bit is reserved for cost, and that known as cell loss priority. Okay, so let's move on again on the class of service bits. If we convert that bits into the decimal and binary, so this will look like this, right? 7 will be look like 111, 5 will be 101. So actually 0 is reserved for best effort, and 1 to 5 is reserved for wise, 6 is reserved for routing protocol, and 7 is reserved for L2 protocol. So actually what is best effort? Best effort means if we don't apply any priority or any marking on any traffic, then that will be the best effort. That means by default mechanism will work first in, first out. But if we apply the marking as 1, then it will be considered as more priority as compared to 0. So here you need to keep in mind that higher value will be always preferred. Okay. So actually here one thing uh, learn here that L2 protocol actually allocated to 7. Why? Actually, as per OSI layer, as we know, first our physical layer comes, after that data link layer, right? So in data link layer, L2 protocol runs. If L2 protocol doesn't run, then how can we suppose that our routing protocol or voice traffic will be over there, right? That's why L2 protocol is given to 7, and higher value will always be preferred, right? And here one more thing we have discussed about the classification and marking, right? So actually we need to purchase the marking from the ISP. If you don't purchase, then we cannot apply, right? If anyway you apply for voice traffic as per our critical applications, then ISP will not consider that. ISP will reject that and will consider all the traffic as the best effort, right? Now our last topic is flow. So actually what is flow? Actually flow is group of packet that has same source IP, destination IP, source port, destination port, transport layer protocol, and cost marking. If all these 6 things matched, then there will be called as one flow. I'm just taking one example. Suppose you are using IP phone in your organization, right? And you have dialed one number. Then there will be always one flow because your source IP and destination IP will be always same, right? So that will be the one flow. But if you are using the multiple application in your PC, like as Facebook, Google, or YouTube, then there will be 3 flow, right? Because your source IP will be same always, but your destination IP will be different. So there will be a 3 flow for that. So this was our agenda for today. So I hope guys you have learned something new today. So thanks for watching. Till the next video, I'm signing off. Take care.